Trigonometry all started off with the Egyptians wanting to construct pyramids. They needed to know how long the side of the pyramid was, knowing the length of the base and the height. So they created a triangle representing the pyramid and inscribed a circle around it, where one corner was in the middle of the circle and the other two corners touched the edges of the circle. Given this triangle, the Greek mathematicians wanted to measure the length of the unknown side. This line which subtends the arc was known as the chord. The chord function can be related to the modern sine function, which came from the Latin word sinus, meaning a bend or gulf. To determine how to calculate a chord, we first take a point 1, 0, and another point, cos theta, sine theta, where cos comes from cosine, which is an abbreviation for complementi sinus. Since this side has length 1, and this is cos theta, this portion must be 1 minus cos theta. Now to solve for the chord, we use Pythagorean's theorem, a squared plus b squared equals c squared. So we get that sine squared theta plus 1 minus cos theta all squared is equal to chord squared theta. Now using simple algebra, we can solve to get that chord theta is equal to 2 sine of theta over 2. Essentially, what they were doing was just measuring the lengths of triangles, which in Greek is trigonometria. And this is where trigonometry came from.
Trigonometry, of course, depends on geometry. The law of cosines, for instance, follows from a proposition of synthetic geometry. Problems in trigonometry have required new developments in synthetic geometry. An example is Ptolemy's theorem, which gives rules for the chords of the sum and difference of angles, which correspond to the sum and difference formulas for sines and cosines.
Where did it originate? Believe it or not, trigonometry dates all the way back to the early ages of Egypt and Babylon. Angles were measured in degrees, and Greek astronomer Hipparchus compiled a trigonometry table that measured the length of the chord subtending the various angles of a circle with a fixed radius r.
Hipparchus was an astronomer, and his knowledge of trigonometry is what he used in astronomy. So, since ancient times, trigonometry was used in astronomy. The technique of triangulation is used to measure the distance to nearby stars. In 240 BC, a mathematician named Eratosthenes discovered the radius of the Earth using trigonometry and geometry. In 2001, a group of European astronomers did an experiment that started in 1997 about the distance of Venus from the Sun. Venus was about 105 million kilometers away from the Sun. Now, some more interesting facts. It is used in architecture. Many modern buildings have beautiful curved surfaces. These curves are out of steel, stone, concrete, or glass, and it's extremely difficult. One way around to address this problem is to piece the surface together out of many flat panels, each sitting at an angle to the one next to it. So, with angles, you can see why trigonometry is used. They have to make these shapes easier for the buildings to be processed, and usually these shapes are like flat shapes, like squares, pentagons, hexagons, and it can be made out of triangles. And so this is why trigonometry plays an important role in architecture for the architect to label out the blueprints and everything.
Book on mathematics. It will tell you that the ancient Greeks discovered trigonometry. Our research into this Babylonian tablet is going to change all of that. Plimpton 322 is a 3,700-year-old fragment of clay from the Old Babylonian period, and it's a scientific marvel of the ancient world. We've known for decades that its unusual sequence of numbers proves that the Babylonians knew the Pythagorean theorem 1,000 years before Pythagoras was born. But while there is agreement on what the tablet contains, there's been no agreement on what it was used for. Our research shows that it's a trigonometric table, so unfamiliar and advanced that in some respects it's superior even to modern trigonometry. We've discovered that these lines represent the ratios for a series of right-angled triangles, ranging from almost a square to almost a flat line. This makes Plimpton 322 a powerful tool that could have been used for surveying fields or architectural calculations to build palaces, temples, or step pyramids. The Babylonians' unique approach to arithmetic and geometry means that this is not only the world's oldest trigonometric table, it is also the only completely accurate trigonometric table on record.
We can see from the previous video clip included in the video that Pythagoras was not the first one to come up with the Pythagorean theorem, and that the Babylonians were the first ones to have a accurate trigonometry table, and it is the only accurate trigonometry table to this day. And the Babylonians are a part of biblical history, and I will be telling y'all in a little bit about how math in the Bible is accurate to this day and how we can see that. The Bible's first mention of Babylon comes in Genesis 10. This chapter is referred to as the Table of Nations, as it traces the descendants of Noah's 3 sons. In the genealogy of Ham, Cush was the father of Nimrod, who grew to be a mighty warrior on the earth. Genesis 10:8. Nimrod founded a kingdom that included a place called Babylon in Shinar. Genesis 10:10. So, the Babylons were first mentioned in the Bible in Genesis 10. And their math is known by the number 60. We see it by the number 60 to this day. And what I mean by that is that the number 60 is what we call 60 degrees today, but the Babylons used it as a numeral and based this off of the number 60, so it may be conjectured that they took the unit measure to be what we call 60 degrees, as I've said. Perhaps 60 degrees was taken as the unit because of the chord of 60 degrees equals the radius of the circle. So the degree measurement was later adopted by Hipparchus, who we have already talked about as an astronomer. So first off, what is chemistry? Chemistry is the study of matter, its properties, and the study of how and why substances combine or separate to form other substances. We use internet research and our chemistry teacher to learn how trigonometry is used in chemistry. A chemist's research and experience with the properties of chemical substances. They measure the effects of chemical compounds in various situations and study interchemical reactions. Also, a chemist uses trigonometry when accurately describing the angles that are created when atoms bond together to form molecules in molecular geometry. Trigonometric functions such as sine, cosine, and tangent are essential to describe materials in their 3 dimensions. Like you have ions and the bonding of ions. An example is molecules want to be as far away as possible from each other when they bond. So, as an example, we have carbon dioxide, boron trifluoride, and methane. Trigonometry comes up in many aspects of biology. One example is X-ray crystallography, a technique used to determine the 3-dimensional structure of molecules. X-ray crystallography has been used to determine the atomic structure of thousands of biological important molecules, including vitamins, proteins, and perhaps most famously DNA. X-ray crystallography exploits the fact that when an X-ray is passed through a crystal, it is diffracted according to the crystal's atomic structure.